Welcome, where, Nunda, Dumalang, Molo, Saubona, Hukandat, and a warm welcome to the Induvo Knowledge Cast, the podcast where your curiosity meets insightful conversations. Today we're stepping into the world of OpenAI's Swarm. It's this experimental framework, all about building AI that can work together, almost like a team. So picture this. A bunch of AI agents, each with its own strengths, coming together to solve problems. That's the basic idea we're diving into today.
What really fascinates me about Swarm is how it challenges the traditional way we think about AI. That whole thing where we try to build one super intelligent system to handle everything. Swarm takes a different approach. It's about embracing a more, I guess you could say, distributed, collaborative kind of intelligence. And, when you think about it, that's how a lot of natural systems actually work.
You've definitely got me curious. I can already see how moving away from that one AI to rule them all idea could be a real game changer. So how does this multi-agent orchestration, as they call it, actually work?
Okay, so imagine you have a complex task. Let's say building a chatbot for a tech company right here in South Africa. Now, instead of trying to design one AI that can handle everything, from understanding like Afrikaans slang to navigating complex technical questions, you could use Swarm to create a team of specialized agents.
So like a whole squad of AI, each with its own area of expertise.
Exactly. You could have one agent that's amazing at understanding natural language, another one that's, say, a whiz with financial queries, and maybe even one that's great at, cracking jokes to lighten the mood.
So it's like having different departments in a company. But instead of humans, it's all these AI specialists working together.
That's a great way to think about it. Now, picture a user interacting with our chatbot. The first agent they encounter is like the receptionist, greeting them, trying to understand what they need. Now, if the user asks about their account balance, for example, the receptionist agent realizes, okay, this isn't my area, and seamlessly hands off the conversation to the agent who specializes in financial queries.
So it's like being transferred to the right department, but instead of waiting on hold, it's instantaneous.
Exactly. And what makes these handoffs so powerful is that the agents can actually share information with each other. So it's not just a blind transfer. The receptionist agent can provide context about the user's previous interactions, which makes for a much smoother experience.
That's really clever. It's like including a quick note before transferring a call so the next person knows what's going on. But how do these agents know what to do and when to do it? Are they just making it up as they go along?
That's where things get really interesting. Each agent in Swarm operates based on a set of instructions and functions. Think of instructions as the agent's overall goals, like guidelines, while functions are the specific actions it can take to achieve those goals.
So the instructions are like the agent's job description, and the functions are the tools in their toolbox.
You got it. Let's go back to our chatbot example. The instructions for our financial specialist agent might be something like, assist users with their financial queries in a helpful and informative manner. The functions, on the other hand, those would be the actions it can take to achieve that, like retrieve account balance, process a payment, or generate a transaction history.
So it's like giving each AI agent a little playbook, complete with a set of plays it can run depending on the situation.
Exactly. And here's where the flexibility of Swarm really shines. These instructions and functions aren't set in stone. They can be adjusted, dynamically based on what's happening in the conversation.
Okay, hold on. Context. We're talking about AI that can actually understand the nuances of a conversation.
Absolutely. Swarm lets you incorporate context variables into an agent's instructions. Imagine you have a context variable for the user's preferred language. So if the user prefers to communicate in isiZulu, the instructions for our financial agent might become,
Siza abaspenzizi ngivivuzo yabo yezezimali neselo seasonal owazi olofolele usbingdesa isiZulu. Wow, so the instructions can adapt to use isiZulu. That's amazing. This adds a whole new level of personalization and responsiveness to the interaction.
exactly, and that's just one example. You can use context variables for all sorts of things, like the user's location, their previous interactions, even their emotional state. This allows you to create agents that are far more adaptable and intelligent in their responses.
I can already picture our listeners' minds spinning with possibilities. But before we get too technical, let's ground this with a real-world example. You mentioned a customer service bot earlier. Can we take a closer look at that?
Absolutely. OpenAI actually has this example of a customer service bot built with Swarm. It uses two main agents, a user interface agent and a help center agent.
Okay, so two agents, each with its own specialty. Tell me more.
Let's say you're having some trouble with Day A, OpenAI's image generation tool. You open up the chatbot, and the first agent you interact with is the user interface agent. Think of it as the friendly face of the bot. It greets you, figures out what your issue is, and basically points you in the right direction.
So it's the first point of contact, making sure you get to the right department, or in this case, the right agent.
Right. Now, let's say our user has a question specifically about daily. The user interface agent realizes pretty quickly that this is a more specialized topic, something that needs the expertise of our second agent, the help center agent.
This is where that handoff we talked about comes into play. The user interface agent knows it's out of its depth and passes the baton to the specialist.
Exactly. The conversation is seamlessly transferred to the help center agent, which has a really deep understanding of DALL-E and how it works. This agent can access a specialized knowledge base, troubleshoot common issues, even guide the user through specific features.
It's all coming together now. Each agent plays a crucial role in making sure the user gets the help they need. As quickly and efficiently as possible, it's all about teamwork, even for AI.
Exactly. And this example just shows how Swarm can be used to build practical AI solutions today.
Hmm.
I mean, even though it's still experimental, it has the potential to completely change how we interact with technology.
Okay, this help center agent sounds pretty impressive. But how does it actually access all this information about DALL-E? It's like having a mini Google built into its brain.
Great question. In this case, the Help Center agent uses something called a vector database, specifically a tool called Qdrant, to store and retrieve information about DALL-E.
Hold on, vector database. I have to admit, I'm not familiar with that one. What's so special about this Qdrant thing?
So think of a vector database as a more, I guess you could say, intuitive way for AI to understand and search information. Imagine you have a library full of books about DALL-E. Now, a traditional database would only look at the words in your search query and try to match them to the words in the books. But Qdrant is smarter than that. It actually understands the meaning behind those words.
So it's not just about matching keywords, it's about understanding the actual concepts and ideas being discussed. That's pretty impressive.
Exactly. Here's how Qdrant does it. It converts each piece of information, like a paragraph from a DALL-E manual, into a vector. Now, a vector is basically a set of numbers that represent the meaning of that information. So instead of just searching for keywords, Qdrant compares the meaning of your question to the meaning of the information stored in its database.
So each piece of information has its own unique fingerprint based on its meaning. And Qdrant can quickly find the most relevant information based on how similar those fingerprints are.
That's a great way to put it. And this is what makes Qdrant so powerful for a help center agent. It allows the agent to give much more accurate and helpful answers to user questions, even if those questions are phrased in a way that doesn't directly match the information in the database.
That makes sense. It's like Qdrant is bridging the gap between human language and how AI processes information.
Precisely. And this ability to understand and respond to the meaning of language, it's a crucial step towards building truly intelligent AI systems.
This is all so fascinating. So we've got our Help Center agent armed with its Qdrant-powered knowledge base, ready to tackle user questions about delay. What else can it do? What other tools or functions does it have at its disposal?
So besides tapping into that knowledge base, the Help Center agent can also do things like sending emails, or even like escalating the issue to a human support team if it needs to.
So it's like it's got this whole toolbox of actions it can take, depending on what the situation calls for.
Exactly. And that flexibility is what makes Swarm so powerful. It lets you create these really dynamic AI systems, ones that can handle a wide range of user needs. But, even with all this talk about agents and databases, there's one really crucial aspect we haven't talked about yet. How does all of this actually work in real time?
Now that you mention it, we've been discussing these separate components, but I'm curious about how it all comes together, as a seamless experience for the user, especially since you mentioned that Swarm itself is stateless.
That's a great point. And it gets at how Swarm actually manages conversation flow. So the statelessness. It basically means that, technically speaking, Swarm doesn't remember past interactions. So to make it feel like a continuous conversation, it uses something called a demo loop.
A demo loop, what is that?
Think of it like the conductor of an orchestra. OpenAI provides this helper function called loop, and it basically orchestrates that whole back and forth between the user and the different agents. It takes the user's input, figures out which agent should handle it, gets the response, and then gives it back to the user. And all the while, it's keeping track of the conversation history. Even though, like we said, Swarm itself is stateless.
So it's like this demo loop is creating the illusion of a continuous conversation, even
Mm.
though behind the scenes, it's more like a series of individual interactions strung together.
You nailed it.
Yeah.
And without that demo loop, each interaction would feel really isolated, like starting a brand new chat every single time.
Okay, that makes sense. But how does this demo loop figure out which agent should be in charge at any given moment? I mean, we've talked about those handoffs between agents, but who takes the lead initially?
That's where the starting agent comes in. Remember how we said that in our support bot example? The user interface agent is like the initial point of contact. Well, that's the agent we would feed into our Rindemult. It's like the default starting point for every user interaction.
So every time a user starts a chat, they're greeted by the user interface agent. And from there, the demo loop takes over, managing any handoffs to specialized agents based on the conversation.
You got it. It's like a really well-rehearsed play. Each agent knows its cues, and the demo loop is the stage manager, making sure everything goes smoothly.
This is really giving me a new appreciation for just how complex it is to build these AI systems. It's not just about programming instructions anymore. It's like we're designing entire conversational ecosystems. But with all this complexity, there have to be some challenges that come with using a system like Swarm.
You're absolutely right. Building multi-agent systems like this is still pretty new, and there are definitely some challenges that developers need to keep in mind. One of the biggest ones is simply managing all that complexity as the system grows.
I can imagine. As you add more agents, each with its own specialities, it could start to feel a bit like herding cats.
That's a great analogy. It's easy to get lost in a jumble of instructions, functions, and context variables if you're not careful. And just like with a human team, clear communication and well-defined roles are super important.
So it's all about organization and communication, just like in any good team. Are there any other potential pitfalls that developers should watch out for?
Another challenge is figuring out how to measure how well these multi-agent systems are actually working. With a traditional AI model, you usually have one main metric you're trying to optimize, like how accurate it is on a specific task. But with Swarm, it's not always that straightforward. You've got multiple agents working towards a shared goal, and it can be tough to separate individual performance or figure out exactly where to make improvements.
So it's not so much about evaluating each agent individually, but more about assessing how effective their collaboration is as a whole, right?
Exactly. You need a more, I guess you could say, holistic approach to evaluation. You need to ask things like, is the whole system achieving what it's supposed to?
Hmm.
Are the agents working together well?
Mm.
Are there any bottlenecks or communication breakdowns that are holding things back?
It's like those team building exercises, where you all have to work together to solve a puzzle or build something. Focusing on how well each person does on their own wouldn't really tell you much about how effective the team is as a whole.
Exactly. And just like with those team building exercises, sometimes the most creative and effective solutions come from unexpected collaborations, between agents with different strengths.
It's interesting how these parallels to human teamwork keep coming up. It really emphasizes that we're not just talking about lines of code. We're talking about building systems that can learn and adapt together, just like we do.
Exactly. And that's what makes this whole area of multi-agent systems so exciting. It's not just about making AI that's smarter. It's about making AI that can work together more effectively, just like humans.
It's like we're moving past this idea of the lone genius AI and embracing the power of collective intelligence. Okay, we've talked about the challenges. Let's switch gears for a minute and talk about the potential. What future applications are you most excited about for this kind of collaborative AI?
Oh, the possibilities are truly mind-blowing. Just imagine a world where these swarm-powered AI systems are helping us tackle some of the biggest challenges facing South Africa, even the whole world.
Okay, I'm intrigued. Paint me a picture of this future.
Let's see. Okay, how about this? Imagine using Swarm to create an AI system for managing water resources in drought-stricken areas. You could have agents that are like experts in monitoring rainfall patterns, others predicting water demand, optimizing irrigation systems, even some communicating with local communities about water conservation, and
So instead of having all these separate piecemeal approaches, we can have this coordinated AI system working on the water crisis from all angles.
exactly. Or picture this. Using Swarm to build more resilient energy grids. You could have agents that are constantly keeping an eye on energy consumption, predicting potential outages, and then automatically rerouting power to prevent those widespread blackouts.
It sounds like Swarm could really be revolutionary when it comes to building a more sustainable and resilient future for South Africa.
And it doesn't stop there. Imagine AI-powered healthcare systems, where you have agents collaborating to diagnose diseases more accurately, personalize treatment plans, even predict potential health risks before they become serious issues.
Wow, these are some really inspiring possibilities. It feels like we're standing on the edge of something truly revolutionary.
And I think Swarm, even though it's still in this experimental phase, is laying the groundwork for that revolution. It's pushing us to think differently about what AI can be, not just these individual agents, but interconnected systems that work together to solve complex problems in a way that aligns with human values and priorities.
It's like we're moving away from this idea of AI as a lone wolf and stepping into the era of the wolf pack, a team working together towards a common goal.
Exactly. And the exciting part is we're just scratching the surface of what's possible with multi-agent systems like Swarm. As more and more developers start experimenting with this collaborative approach, I think we'll start seeing even more creative and impactful applications pop up.
It's like we're handing the paintbrush to a whole team of AI artists and
Oh,
saying, go wild. Let's see what you can create together.
I love that. And I have a feeling we're going to be amazed by what they come up with. But for now, I'm curious, what stood out the most to you in our exploration of Swarm today?
Honestly, what's really blown me away is the sheer potential of this whole collaborative approach. It's like we're moving beyond just teaching AI to do things for us, and we're starting to explore how to teach it to work with us, almost like a real partner in solving problems.
I couldn't agree more. That shift in thinking from AI as a tool to AI as a collaborator, that's where the real magic is, I think. And tools like Swarm are giving us a glimpse into that future.
It's like we're not just building machines anymore. We're building teams, AI teams. But for our listeners who are eager to jump in and start experimenting with Swarm themselves, where would you recommend they begin?
Well, OpenAI has been great about making Swarm really accessible. For anyone who wants to dive in, I'd say the best place to start is their official Swarm repository on GitHub. You'll find everything you need there: documentation, code examples, even practical examples like that customer service bot we were talking about.
So it's like they've provided all the blueprints, the building blocks, and now it's up to the community to experiment and see what incredible things we can build together.
Exactly. Don't be afraid to get your hands dirty. Experiment with different ways to set up the agents. Play around with different functions. Maybe try to build your own version of that customer service bot. Or even come up with something totally new. That's how we learn. That's how we push the boundaries of what's possible.
And who knows? Maybe one of our listeners will make the next big breakthrough in collaborative AI.
Wouldn't surprise me at all. The future belongs to those who are willing to explore, experiment, and collaborate. And with tools like Swarm, that future is looking brighter than ever.
It certainly is. So from streamlining those complex workflows to creating more intuitive and helpful AI assistants, Swarm is giving us this really exciting glimpse into the future of collaborative problem solving. It really gets you thinking, what seemingly impossible challenges might we be able to overcome if we can harness the power of AI teamwork? Something to ponder for sure.
Absolutely. A future overflowing with possibilities.
It certainly is. And on that note, until next time, keep those minds curious and keep those questions coming. This has been the Induvo Knowledge Cast, where your curiosity meets insightful conversations.